Hi, my name is Abby Torno.
And I'm Ann Sigmund, and our proposal questions how architecture can bridge a gap between biology and technology. Our proposal, Synthesis, is a space that utilizes computation and fabrication to construct sustainable and efficient building skins. At the simplest level, an architectural building skin is responsible for providing thermal comfort and protection to its users. But what if a building skin was able to provide for more of the user's needs? Our site is located in Des Moines, Iowa, at a historic Union Depot in the East Village. Throughout Des Moines, we see a range of building skins, from the gold-gilded dome at the Capitol to the copper glass at the Chipperfield Library. These important buildings have become architectural icons for the city. But what if we widen the range of building skins throughout Des Moines and use today's knowledge of computation, technology, and science to maximize efficiencies and sustainable practices? Our architectural proposal allows a space for fabrication and testing of future building materials.
The existing historic Union Depot will remain on the site, and our new addition will provide a space for building materials that can be fabricated and studied. Our building houses robotics labs, education classrooms, and a public cafe. The site has direct access to the old railway, which the city is converting into a bike path. This allows good public access to the pavilion space. We have organized our building to maximize our surface area of the south facade. This is where we have designed our own building skin. This will be marked as the first adaptive facade in Des Moines. The south facade is important because of its access to sun throughout the day. The orientation of our building allows all of our servant spaces, such as mechanical, bathrooms, and circulation, to be the north of the site. This allowed us to utilize the south of the massing for robotics labs that we can be viewed from the exterior. Our circulation runs in between the served and servant spaces. The public has access to a majority of the first and second floor, excluding the robotics labs, and the third floor is private space reserved for the research team.
Our main entrance is on the east of our building next to the historic Union Depot. This is where our lobby and shop are located. This also includes a storefront of the existing depot that houses administrative offices. Further into the center of our building is our public cafe and dining area, which has great access to the outdoor pavilion. Our lower level houses our first robotics lab that uses KUKA arms for fabrication. The public is able to see this lab from the hallway running along the first floor. The hallway also allows a view into the second fabrication lab. The second floor has our education classrooms that include a small exterior patio. The third floor has offices for the research team, an outdoor patio for events, and the remainder of our robotics labs. Materials are delivered and enter the lab space on the west. We have a freight elevator to move materials to all floors. The lower and second floor are fabrication labs utilizing robotic computation. The third floor is where material testing takes place, looking at structural, thermal, and weathering properties. We have control rooms that are able to manipulate the atmospheric qualities of the space in order to test the properties of the building materials.
Our structure allows us to have an open floor plan for our lab space, pushing all columns to the exterior. We are utilizing trusses to convey a light and open environment. We have placed thermal chimneys in the center of our building to passively cool our cafe, dining, and classrooms. We have separated the remainder of the square footage into 3 mechanical zones to heat and cool our building. Our facade is attached to a curtain system set with the structure. The facade shades the interior space of our building to help reduce our cooling loads. The facade is constructed from soft robotics PV arrays. The PV soft robotics will move orientation to follow the sun path. The skin mimics heliotropism, the motion of plant parts in response to the direction of the sun. Plants use this process to maximize photosynthesis for energy, and we are utilizing a similar process to produce renewable energy for our own building. In order to construct our building skin, we have broken up the south facade into varying module sizes. The diagram shows the module dimensions and where they are located on the facade. The facade skin attaches at the curtain wall mullions. We are utilizing custom brackets to vary the distance of the modules in order to create a fluid skin wrapping our building.
The skin is able to diffuse direct daylighting into large spaces like our labs and atrium. Visitors have a visual connection to the facade from both the interior and exterior. Our project is meant to be a space that welcomes the public to learn about current research being conducted using today's technology and knowledge of sustainable architecture. Visitors view the experiments as a gallery as they walk the circulation path of the building. The results of the research being conducted is then able to become public knowledge in order for new buildings in Des Moines to utilize.
The exterior of the building showcases how engineering new facade systems can create new architectural icons for the city. As our project will be the first adaptive facade in Des Moines, it is meant to be a catalyst for future building skins.